Good morning. I just wanted to zoom in here with you. Actually, I'm not zooming. I'm doing something here on Notability. This is the worksheet on the back of your guided notes for central limit theorem. Okay, so you've got two formulas you're working with. Okay, if a problem is talking about finding the probability that the mean is doing something, okay, then we use the central limit theorem formula for calculating your z-score, okay, which is this new one for this week. Okay, once you get your z, you're converted to z. Actually, your problem kind of goes like this. You'll have x bar doing something, okay, greater than, less than, equal to, depending on the problem. Convert to z using central limit theorem formula. Then from there, you're using your friend normal CDF, okay, just like we did previous week. Okay, so again, this worksheet's on the back of your guided notes for central limit theorem. Okay, so let me show you what I mean about this, the mean doing something, okay? So I'm going to look in this first question, and it says, find the probability that, okay, 45 randomly selected. All right, so 45 is an N, that's your sample size. CDs will have a mean greater than 7. So as soon as it says the mean greater than 7, that means you have a central limit theorem problem, and you want to use this new z conversion that we've been working through with this week. Okay, so like if you went to set this one up now, converting, you would say z is greater than 7 minus the population mean, which is this one right up here. Okay, that's that mu that we've worked with, all over standard deviation is 1.4, divide by the square root of the sample size, sorry, which is over here 45. And I would parenthesis that up. I usually do the top, press enter, and then divide by and put the parentheses on the bottom. So for this z, I came up with greater than negative 0.48. Okay, so then I would either draw a little picture, negative 0.48, and then I would go out here to positive infinity, or if showing it in your calculator, normal CDF, negative 0.48, 1E99, okay, and I came up with 0.6844 for an answer, okay. So again, let's kind of go through here. Just look at the questions here. Like number 2, it says, find the probability that the mean is between 11 and 12. So 11 is less than x bar is less than 12. Because it says the mean, then you'll use this new z formula for central limit theorem. Okay, next one down here, find the probability that the mean exceeds 7. So again, the mean greater than 7. And then you use the new z formula. Okay, let's see, well, this one just says flat out use central limit theorem. So let's come down here to number 5. Okay, so it goes through all this stuff. A bottling company uses a filling machine to fill plastic bottles with cola. The bottles are supposed to contain 300 milliliters. In fact, the contents vary according to a normal distribution, okay, so it's going to bell-shaped, with a mean, okay, that's going to be your mu, 298, and standard deviation, 3. Okay, so in A, what is the probability that an individual bottle contains less than 295? It does not say the mean. So it doesn't say the mean. So that means we'll start out just plain old x, less than 295. Then we use, I'm writing down here at the bottom, the form, I'm sorry, I'm trying to go too quick. X minus x bar over s. This is the one from last week. Okay? So that's what you're going to use up here on 5A. So z less than 295 minus 298, the mean up here, divided by 3. Okay? And if you do that, you get that z is less than -1. Okay? And then if you do normal CDF, you can do negative infinity to -1, and you get like 0.1587. Okay, now, different from what we have here in B, okay, because it says, what is the probability that the mean in a 6-pack less than 295? So it feels like it's the same, but it says the mean. So that means, no pun intended there, that X bar is going to be less than 295. Then we use central limit theorem to convert to Z. So 295 minus 298 divide by standard deviation, square root of, and I underlined over here, 6 is your sample size. Okay? So then when you convert this one, you should come up with something like negative 2.45 for your Z. So then it's normal CDF, negative infinity, negative 2.45. Okay, and if you plug that in, it's like 0071. Okay, or you could have drawn a picture, negative 2.45 and negative infinity, okay, and leads you to that as well, okay? All right, so that's the difference in the two formulas. Central limit theorem over here, okay, and you're looking for the question to say the mean when you're doing probability. The mean is doing something, okay? This one doesn't say that. It's just individuals, no mean, and there's no sample size over here either. That's another way you can tell. No sample size. This one has a sample size. Okay, hope that helps. I'll get this link sent to you. Have a good day.